a warm welcome, please. Come on. There you go.
All right. Hello, everyone. Welcome. Thank you to you all for coming to listen to us today, including those of you who didn't have a choice. My name is Liam. We are Team Jog On. I'm just going to be giving you a little intro to our app today before passing you on to my team members who will go a little bit more in depth. So for a little bit of context, imagine that you're planning to go for a run and you want to map out your route, something that myself and a lot of other runners I know like to do beforehand to get a good idea of distance and time and that sort of thing. This is all well and good until you get to the halfway point on your run and you realize that the footpath on the road you were planning on running down just ends. Or maybe the side street you wanted to take a shortcut through has no street lamps, it's pitch black, and you suddenly don't feel so safe anymore. This is exactly the problem that our app is built to solve. So Jog On is a community-driven running app where you have not only the opportunity to help out your future self, but also other runners. You may be familiar with an app called Waze. It is a now Google-owned app that provides live traffic updates based on the feedback provided by other users of the app. Jog On operates on a very similar principle. It allows you to record the route that you've run and then note on that route any issues that you spotted along the way. Then once you're done, that route and the markers that you put down to note any issues, they are then accessible to all users of the app who then have the capacity to plan their route accordingly, hopefully circumventing any mishaps you might have had, or in the event of a completely issue-free run, they already have a worry-free, pre-planned route. So, to give you a better idea of how this works, we now have a demo video for you, narrated by Patrick.
The application loads up to a nice splash screen of our logo, followed by a sign up or sign in page powered by AWS Cognito. Users signing up will be provided with an authorization code via email, which they will be prompted for. For the purposes of this, our user is already signed up. Once you've signed in, you are taken to a map screen where you can immediately view issues which are represented by markers. To save processing time, we set up the API call to be specific to your area, and this will only fetch additional markers when the screen moves far enough. If you want to hide the markers, just tap this button. There is also a quick key for issue types, a navbar at the bottom, and a start button to begin recording. If this is a new route, you will see one line tracking your progress. We chose Liam Duncan to do this run due to his inhuman speed. When you are done, just tap stop. You will be presented with a few question screens checking if you ran into any problems and then be shown any existing markers for that issue. For example, mud or poor lighting, and add your own which snap to the route you ran. If a marker is accidentally placed, you are given an opportunity to remove it. Upon completion of these questions, you pick a name and submit the route. Our Lambda function then it ingests the route and then adds your markers to any affected routes to help other users and then adds it to your personal route list. On your route list, you can see all your routes or all public routes, and each route card gives you the name, the length, and any issues flagged on that route. These results are paginated to limit the load on our Lambda function. All routes are sorted by distance from the user by default. Additionally, users can choose whether to display the distance in kilometers or in miles and turn on a dark mode for late night running. When a route is selected, it returns the user to the main page from which they can follow the existing route and track themselves as they run.
Hi, I'm Simon and I'm here to tell you about our front end. So initially we did some spiking with Kotlin as we were aware of the popularity it's currently got in industry. But we were drawn to React Native mainly because it allowed us to create both an Android app and for it to work on iOS as well. So during the spiking, we came across a package called React Native Maps that allowed us to get up and running with maps really quickly. And that was really the main thing that convinced us that React Native was the right thing for our project. So whilst we did know React, having been taught it on the course, React Native was completely new to us. And we found that whilst there were some similarities, there are also quite a lot of differences. But after spending quite a bit of time in the React Native docs, we got much more comfortable with it. We also used Expo. That gave us a really great developer environment and really allowed us to spend more time actually writing code rather than setting up tooling, and gave us a great platform to carry out a lot of user testing on both iOS and Android devices as we were in the development process. Before we actually did any coding, we created some designs in Figma. That proved to be a great step, as it allowed us to really think through the user experience and how we might need to structure our app in order to deliver the experience that we wanted. So I'm going to pass you over to Liam, who's just going to tell you a bit more about the front end.
So it became evident pretty quickly, a few days into the project, that navigation was something that was paramount to be sorted out. So after Simon and I spent some time studying the docs, and we managed to plan out a basic setup for our app, we then split apart, separated into pairs to try and fully flesh out the screens of our app in order to get something that resembled a fully functioning app. Working in this way was very beneficial, as it allowed us to really realize the true benefits of pair programming. It enabled more of the members of our team to really bring their invaluable insight to the front end of the project. In addition, naturally, as Simon mentioned, we always were focusing on having a very pleasant user experience. Part of this was working on a balance of what processing should be done on the front end and what processing should be done on the back end, including dealing with problems like ensuring no difficult loading times for users. One of the ways that we helped make this work was with a couple of util functions. With the aid of a very useful package called geolib, we were able to calculate the length of a run without accessing the Google Maps API, which was a big time saver. And in addition, as was mentioned in the demo video, we were able to limit the number of API calls made to our own backend by only refreshing the markers on the screen after there had been a sufficient change to the region shown on the map. I'll now pass you over to Liam, who will go in a bit more in depth on the backend infrastructure.
Hi, I'm going to talk to you a bit about our tech choices and implementation. So we decided pretty early on to go for an AWS-based serverless backend. We did try some initial spiking with Google Cloud Services, but decided due to the relational nature of a lot of the data that we were dealing with, that Amazon RDS would suit us a little bit better for that. We were also drawn to AWS because it's somewhat of an industry standard. None of us had any experience with it, and we're all pretty excited to try something new. So our stack here is comprised mainly, the back-end side of it, of our Node.js server running on an AWS Lambda function. We interact with that through the Amazon API gateway, and this interfaces with the Amazon RDS server. Authentication is powered by Amazon Cognito, which proved to be a very robust solution and was pretty easy to implement into our Express server using the Cognito Express package. And that allowed us to secure our otherwise public API. As Patrick mentioned in the demo video, and Liam alluded to as well, we put a lot of effort behind the scenes into limiting the workload of our AWS Lambda function. That was through limiting our API calls, leveraging the computational power of our database using PostGIS, and obviously client-side rendering as well. Theoretically, because of these efforts, we should be able to scale this application to a lot more concurrent users than we've currently been testing it with. And on the lowest tier of Lambda, our most expensive requests will rarely over 1 second. I'm going to pass you over to James now, who's going to talk a bit more about our backend processing.
So for the backend processing, our fully tested Express server accepts authenticated requests from the front end. So as an example, a route might look something like this. It would be an encoded polyline. The backend then decodes that polyline and gets extra information from it, such as an area in which all of the routes are contained and a start location. The area is then used to make its own request of the database to get all of the flags. And then for each flag that's in that area, it's checked against a radius of a point. So if a point is close enough to a flag, then they are added to a junction table, which tells you that this flag is on this route, which is then used in the routes list to show which routes are affected. The user location, the start location, sorry, is also used in the PostGIS request to determine the distance from the user's location in order to order the routes list by distance. I'm now going to pass over to Dave to talk about the problems we faced.
Okay, so yes, as James said, I'm just going to discuss a few of the problems that we encountered during the project and some of the things that we think we might do differently given the opportunity to do it again. So top of the list is React navigation. I know Liam just went through this very briefly. The very nature of the project is that we are sort of learning as we go, implementing a sort of stop and spike basis where we encounter some issues. We have to sort of step back from the project temporarily to sort of overcome these before we can jump back in. Finding some similarities between React and React Native seem to only sort of accentuate the discoveries of their differences. You know, we'd find ourselves in a position where we think we're more familiar with it than we really were. So some of the difficulties were when implementing React navigation was that we already had our pre-made pages in place, which was quite difficult. So we found we had to sort of roll back to quite a bare bones skeleton version of the navigation so we could actually successfully traverse between pages. Then we could reintroduce our pre-made components into that. Another pitfall was some of the nuances of React Native when developing for both iOS and Android. We found one evening that our iOS version was suddenly missing quite a large chunk of functionality, which did, however, emphasize the value of version control with GitHub. We're quite a large group. There's 6 of us all collaborating on the repos. So we were able to go through our commit history, track down where the issue took place, and then we were able to rectify it. So on doing this project again, we now know that we'd have more of a consistent basis of testing both platforms regularly as we sort of head through the projects. In terms of the back end, the initial setup of AWS was quite complicated, simply just due to our unfamiliarity with it. Setting up the initial database, there was a lot of tinkering involved to get proper communication going between the front and back ends. Once we had this set up, I was quite obsessive in checking all the back end git ignore files because it was my credit card that was up for grabs. Beyond that, the PostGIS, which was the geographical extension to our Postgres database, was discovered quite late into our development. This did sort of come with some issues because we would have implemented it sooner had it been found earlier on. We could have taken some of the weight off of our utility functions and implemented those directly with some SQL queries. So prior to the discovery of PostGIS, we found that the curvature of the Earth was quite frustrating. We found that if the Earth was flat, it'd be much simpler to calculate the conversion of the long and latitude points into actual distances. And we also realised that early builds of the app would have performed poorly in the North Pole. But it wasn't MVP, so we decided not to focus on that. But despite some of the issues that we came into, I think we had a relatively smooth process. We had our Trello board that we could all access simultaneously. We had our daily stand-ups, so we could check on other team members' progress. We could redistribute resources where we thought some issues were sort of lagging behind. Not necessarily a technical issue that we came into, but waiting until potentially the wettest day of the year to start putting some routes into our database was a bit of a mistake because we had to go out in what was going on yesterday to get that filled up. But beyond that, I think it's been a very enjoyable experience throughout. Thank you very much for listening. I think we're going to open up for questions. Yeah.